You know, cloud storage, it really does feel like magic, doesn't it? You snap a photo on your phone, and just seconds later, there it is on your laptop. Or you upload a document, and a colleague halfway across the world can open it instantly. There are no disks, no drives, nothing you can see. It just works. But that completely seamless experience brings up a pretty big question. When you save something to the cloud, where does it actually go? Well, in this explainer, we're going to pull back that curtain. All right, let's get into it. This ability to get to your data from anywhere, on any device, whenever you want, it really does feel like a modern magic trick. But behind that illusion is one of the most complex engineering systems that has ever been built.
And that right there is the key. None of this is magic. It's a truly staggering amount of physical infrastructure. And once you grasp that, you'll understand how the cloud really works.
So let's start at the very beginning. When you upload a file, it doesn't just vanish into some kind of digital ether. No, it travels through the internet to a very real, very physical place. And that place is called a data center. Just picture these huge, incredibly secure warehouses packed with row after row of servers, which are really just powerful computers built for one thing: storing and processing data. This is the physical heart of the cloud. But here's where it gets really interesting. Your file isn't just saved as one single file on one single hard drive. Instead, the system actually breaks it into smaller pieces, we call them chunks, and then it scatters them across many different server machines. And the reason for doing this is absolutely fundamental to the design of the cloud. So why do that? Well, it's all about building a system that can handle failure. See, individual hard drives fail. They fail all the time. The cloud is designed with the absolute expectation of failure, and it has a very powerful strategy to make sure your data is safe when it happens.
That strategy is called redundancy. And at its core, redundancy is simple. It just means making multiple copies of your data. So if one server holding a piece of your file goes down, no problem. The system can instantly grab that exact same piece from another machine where it was copied.
And this shows you the process perfectly. Your file gets chunked up, and then those chunks are replicated or copied. But crucially, these copies aren't just sitting on different servers in the same building. They're very often stored in totally different data centers in different parts of the country or even the world. This protects your data from things like a fire, a flood, or a major power outage in one region.
Now, this deep commitment to redundancy leads to a level of reliability that is almost hard to believe. The major cloud providers design their systems for what's called 11 nines of durability. What that really means is that the chance of the system actually losing a file over a year is astronomically small. Your data is, by design, incredibly safe.
Okay, so we've got our files safely stored in little pieces all over the globe. But that brings up a new problem, right? How does the system find all those little pieces, put them back together perfectly, and get them to your screen in the blink of an eye?
Well, that's the job of some highly sophisticated software called a distributed file system. You can think of it like a master indexed or traffic controller that is constantly keeping track of where every single data chunk is. So when you ask for a file, this system coordinates the whole retrieval and reassembly process, and it does it all in milliseconds.
And this same intelligence is what makes syncing files so efficient. For instance, if you change just one sentence in a huge document, the system doesn't have to re-upload that entire thing. It's smart enough to identify and upload only the tiny piece that actually changed. That saves a ton of bandwidth and makes the whole sync feel instantaneous. Of course, keeping your data safe isn't just about making sure it's not lost. It's also about preventing anyone from getting access to it who shouldn't. And this is where another critical layer of security comes into play. Cloud systems protect your data using two main forms of encryption. First, there's encryption in transit, which scrambles your data while it's traveling over the internet, from your computer to the data center. Then there's encryption at rest, which keeps that data scrambled while it's physically stored on the server's hard drives. And this is just a vital layer of security. It means that even if somebody were to physically break into a data center and steal a server, the data on those drives would be complete and utter gibberish without the unique cryptographic keys needed to unlock it.
So far, we've looked at the individual pieces, the storage, the redundancy, the access, and the security. But now, let's zoom all the way out and just appreciate the breathtaking scale of this entire system working together.
A single, simple action like uploading one file kicks off a whole symphony of interacting components. You've got load balancers directing traffic, storage clusters managing the disks, replication systems making copies, and monitoring tools constantly watching for any failures. And it's all orchestrated seamlessly behind the scenes.
This massive, distributed system makes another key feature of the cloud possible: elasticity. Think about it. When millions of people suddenly start uploading photos after a big concert or a holiday, the system doesn't crash. It just automatically scales up, dedicating more server power to handle that spike in demand. And then when things quiet down, it scales right back down.
So the next time you save a file to the cloud, remember what's really happening. It's not just floating out there in some abstract space. It's a tangible collection of bits, chunked up, copied, and encrypted on real hardware, sitting inside real buildings, all managed by one of the most sophisticated systems on the entire planet.
What feels so incredibly simple and effortless is actually the result of immense planning, engineering, and execution. It's not magic.
It's infrastructure. And that really is how cloud storage actually works.